recent trend in robotics is to get lots of robots working together. But parallel operation is not always enough. Some tasks are just too difficult for the robots to solve on their own. So-called self-assembling robots can combine forces by connecting to each other in a broad range of morphologies. But it's hard for the robots to know when to use different morphologies because of their limited local sensing range. The solution? Flying robots. Flying robots can analyse the environment to see what task needs to be solved, what morphology is most appropriate to solve that task, and which robots are best placed to form the morphology. However, it is non-trivial for the flying robot to communicate with specific robots on the ground. The problem is that the robots have very different views of the world, which makes it difficult for them to agree on a common frame of reference. We have developed a method that allows robots to select their communication partners without relying on any kind of global coordinate system. We refer to our method as spatially targeted communication. Let's say a flying robot wants to communicate with a specific robot on the ground, this one, for instance. To start the selection process, the flying robot illuminates its red LEDs. To join the selection process, the robots on the ground light up in blue. In a series of elimination steps, each ground-based robot independently displays a sequence of randomly selected colours. At each step, the flying robot matches the colour of the target robot. Whenever a robot on the ground sees that its own colour doesn't match the flying robot's colour, it eliminates itself. The process continues until only the targeted robot is left. An extended version of this method allows adjacent groups of robots to be selected and then given movement and morphology formation instructions. Here, the flying robot has already targeted the 4 robots closest to the hill and instructed them to form a line morphology. Spatially targeted communication expands the potential of self-assembling systems by allowing ground-based robots to benefit from cooperation with flying robots. Any robotic platform equipped with LEDs and a standard camera can participate in spatially targeted communication. Our current focus is on bringing our research out of the laboratory and into the real world.